All right, if you're building anything with AI, you know you're in a constant battle with two things: latency and cost. Well, today, we're going to dig into the one strategy that helps you crush them both: smart caching. Let's get into how this pretty simple idea can make your AI faster, way smarter, and a whole lot cheaper.
I mean, it's the question every single developer asks themselves, right? You build this incredible AI agent, it's supposed to be amazing, and then you realize it's kind of sluggish and it's racking up a huge bill. But what if the fix isn't some crazy new algorithm, but actually a classic computer science trick that's just been totally reimagined for this new AI world?
This quote from Redis it hits the nail on the head. Look, these large language models are powerful, no doubt, but they have this one really bad, really expensive habit. They will happily reprocess the exact same info again and again and again. So the real question is, how do you stop that expensive, repetitive work?
Okay, so our first line of defense is a technique called prompt caching. You can think of this as the most straightforward, most fundamental way to stop your model from doing the same job twice.
So let's break that down. The real magic of prompt caching is that it saves the processed prompt. It works by remembering the first part of a request, that initial fixed chunk of text. If someone else sends a prompt that starts with the exact same words, the system just reuses the work it already did. No need to start from scratch. And this right here perfectly illustrates the problem. Without caching, asking your AI a new question about, say, a huge document is like making it reread War and Peace from page 1 every single time. It's just so inefficient. Prompt caching is basically like putting a bookmark in the book. It lets the model jump right to the part it needs without all that rereading.
So how does it actually work? Well, the mechanics, as OpenAI lays them out, are pretty simple. The system takes the beginning of your prompt and creates a unique fingerprint for it, a hash. Then it just checks, hey, have I seen this exact fingerprint before? If the answer is yes, boom, that's a cache hit. You get an instant speed boost. If it's a no, that's a miss, and the prompt gets processed like normal, but then saved for the next time.
And the benefits? They are huge. We're talking way faster responses, more consistent results for your users, and get this, up to a 90% cost reduction on input tokens. That is a massive, massive saving. But there's a catch. This only works when the prompts are exactly the same. So what happens when they're not?
And that brings us to the next level, semantic caching. Now this is where things get really, really smart. We're moving beyond just matching the exact words to actually understanding the meaning behind what the user is asking. The key difference here, the big idea, is that we're shifting from exact match to semantic similarity. So instead of looking for identical words, this technique uses what are called vector embeddings. You can just think of them as numerical fingerprints of meaning to figure out if two totally different sounding questions are actually asking the same thing. This is a perfect example, right? One user might ask, how do I reset my password? Another one might say, I'm locked out, how do I get back in? Now, a traditional cache would see two completely different requests, but a semantic cache is smart enough to know the intent is exactly the same. So it can just serve up the same pre-made answer to both users, and you avoid another expensive call to the LLM. All right, so let's put these two head-to-head, the caching showdown, because really understanding when to use each one is the key to getting the biggest bang for your buck. And this table just lays it all out perfectly. Here's the bottom line. Prompt caching is simple, it's often automatic, it's fantastic when you have a big, fixed context that gets used a lot, like a technical manual. Semantic caching, on the other hand, is a bit more complex, sure, but it's way more powerful. It's built to handle the messy reality of how real people talk, all the different ways they can ask the exact same thing. But what happens when these things go wrong? Let's talk about the real-world impact for a second and this hidden danger of something called a silent cache miss.
And this is the really scary part. A cache miss can happen and you'd never even know it. Your API might return a 200 OK status, and from the outside, everything looks perfectly fine. But behind the scenes, a failure in your cache is forcing an expensive call to the LLM, absolutely destroying your performance and your budget, all without leaving a single obvious error in your logs.
And we've got hard data on this. Research from Catchpoint found that a single semantic cache miss increases your latency by more than 2.5 times. That is a massive, tangible performance hit that your users are definitely going to feel. Just look at this chart. It really puts that 2.5x penalty into perspective. A cache hit gets you a nice, snappy 2-second response. Great. But a miss on that very same query?
That stretches the wait all the way to 5 seconds. In conversational AI, that's an eternity. That's the difference between a user having a great experience and one who just gets frustrated and leaves.
So, the big question is, how do we get the best of both worlds? Well, the pro move here is not to choose one over the other, but to use them together. It's a smart, layered approach called double caching.
Okay, so here's how it works. First, you use prompt caching to handle that big, static chunk of text, like an entire knowledge base document. This saves you from having to reprocess that huge file every single time. Then, you layer semantic caching right on top of that to handle all the different ways a user might ask a question about that document. It's an incredibly efficient 1-2 punch.
So what are the big takeaways for anyone building with AI? Number 1, caching isn't just a nice-to-have anymore. It's absolutely critical for performance. Number 2, use prompt caching for those large fixed contexts. 3, use semantic caching to deal with all the varied ways your users ask things. And finally, for the most powerful and efficient system, you got to combine them both.
And that leaves us with one final, pretty critical thought. You've seen the 2.5x latency penalty, and you know these failures can be completely invisible. So the question I'll leave you with is this: are silent cache misses secretly derailing your AI's performance and burning through your budget right now? It's something every developer needs to be thinking about. Thanks for tuning into this explainer.